Okay guys, we should be live. Let me double check. Just a second. Sorry about the abrupt ending of the previous stream. Basically the battery died, and because we only had 10 minutes left either way until the end of the first stream, I was just like, let's make a bit bigger break and then start 3:30 p.m. and so here we are. Let me wait for some people to maybe join here, and then we can start where we ended. And we ended trying to run the extract.py file just to analyze some wiki matrix data. Guys, let me know if you can hear me, if the sound is all right. Let me just, I actually don't need these headphones, earbuds. I'm gonna remove them. You should be able to hear me still. Let me know if you have any issues with the audio. Okay. Just confirm you can hear me nicely. Okay. Let's get started. So there is no such file or directory here. So we're trying to just unzip the Wikimatrix English to Serbo-Croatian dataset. So let's see what's up. Why is it complaining? Probably because the path we have here is not absolute. So let's maybe just grab the whole path and then pass that thing in. So this should now hopefully work. Let's go to extract and let's run it. Okay, Wikimatrix should be good there. And then we have a couple of other tasks left after this one in the laser directory, laser repo, and then we're gonna see what are the next steps. Potentially we can immediately start preparing the data to train the 600 million checkpoint. For that one, I can use literally my current rig. I have 48 gigabyte of VRAM, 2 RTX 3090, so it's going to be enough to train that one. Probably not super fast because we don't have any significant data parallelism, but it's a good start. Okay. Again, VS Code is slow for some reason, even though I've deleted the extra files I had, so I'm not sure at this point why is it so slow. I'll start restarting the operating system. Maybe there's just some glitch. Ubuntu is not that stable compared to Windows. That's my experience so far. I mean, I've been using it historically every now and then, but never as my main operating system. Okay, here it is. It's starting, and now we're going to open the file, and then we're going to create two output files here, and let's start reading the lines one by one. Okay. And the first sentence is, in the name of God, the compassionate and merciful. Because a lot of these language directions are basically, Bible is one of the main sources to get the parallel data, which is interesting. Okay, so here is the data, and then basically, let's see what we do. We basically store those lines in separate files, and then we can just run this and get the final result. We wrote 224,000 lines. Okay, with that many target words, and the threshold is like this. Okay, let's now find those files. Let's see where they are stored. I can see them here. So I'm just gonna split English and Serbian. Interesting. So after, interesting, we have Serbian and English here. Okay. Let me just open up them side by side. Here is the English version. Here is the Serbian version. In the name of God, like you can tell this is not really Serbian because nobody would say Allah in in Serbian. She said, the women are the ones who write the history of the world. Ona je rekla, žene su te koje pišu istoriju svijeta. Plus, when you see J in Serbian, that means this is not really Serbian. This is probably either Bosnian or I guess even Montenegrin. But I would say because of Allah here, it's probably Bosnian language. It's not perfect. Let's sentence 26. I hate the government. Okay, mrzim vladu. Okay. Yeah, this looks like a good translation. It is indeed parallel corpus. It's not really purely Serbian corpus, although I'm fairly sure it will be hard to find perfect corpus for these languages because they're all fairly similar. They're basically dialects of one another. Serbian, Bosnian, Croatian, all of these languages are pretty much the same language with variations, maybe dialect or maybe even language. I think that's the term when the languages are so similar that it's not even a dialect. Okay, let's see. I think that's enough. We don't have to really spend any more time here. So Wikimatrix is basically, we can use it to train our NMT systems, and it's for commercial use cases as well. So that's cool. That's awesome. I think we read this already. Yes, we did. So I'm just gonna note somewhere that we can use. Let me go here. Day 1. I don't think Wikimatrix was mentioned here. So here is just like the names of the data sets and the licenses, and the green ones are permissive ones. So I'm going to just note here that Wikimatrix can also be used to train our NMT systems. And it's actually permissive license. It's CC BI share alike 40. If I remember correctly, that's the correct one. And let me just move this here. And then let's go back to day 3. So the next tasks are just go through all of the leftover tasks in Laser, plan for the next steps. Okay. Let's get started. After Wikimatrix, we have a couple of tasks here left. We have the WMT22. Let's see what this README says. More information on the shared task can be found here. Okay. Downloading encoders. Run the download model script within this directory. This will place all supported models within the directory. Encoders for each focus language are in the format Laser 3, except for Afrikaans, English, and French, which are supported by the Laser 2 model. Available languages are blah blah blah. Embedding text. Once all encoders are downloaded, you can then begin embedding text by following the instructions under there. Okay. So that means we can skip this. Let's go to NLLB preview. This code shows how to use the multilingual sentence embedding for cross-lingual NLI using the XNLI corpus. We train the classifier, optimizing the meta parameters on the English XNLI development corpus. We then apply that classifier to the text set for all 14 transfer languages. The foreign languages development set is not used. Okay, we train an NLI classifier on the English, optimizing the meta parameters, and then we transfer to 14 languages. Okay, just run bash, which installs the XNLI and multi-NLI corpora, calculates the multilingual sentence embeddings, and trains the classifier and displays results. Okay, the corpus is available here. Okay. You should get the following results for zero-shot cross-lingual. They slightly differ from those published in the initial version of the paper. Okay, just a second. Let me just put the stream here so I can see your questions, if there is any. Okay, and there are some references. Let's just check out what these scripts do. Okay, just some download links. Installing. If the TSV does not exist, we download the zip, unzip. Okay, and then for all of the languages, we tail n +2 TSV grep cut field 7, some data manipulation here. What does tail do? Tail n +2, what's that? Is that like the end of the file or something? What does the last part of the file? Yeah, the number of lines. Okay, so when you use all lines starting from that line number up to the end of the file or stream. All lines from the second line to the end of the file or stream, effectively skipping the first line. Often used to remove the headers or titles from the beginning. Okay, makes sense. Again, just some document-specific detail, and then we get those files. That's the XNLI, and then there is the XNLI MT. What's the difference here? MT translated data is already tokenized. Okay, so this guy here is already tokenized. Okay. Okay, thank you for letting me know. So we are just now extracting and downloading the two data sets, and then we export Python path. We just add this Jieba thingy. I think that's the Chinese sentence processor or something like that, sentence splitter. and then we call the XNLI script, which does something, and then we finally call the NLI. Okay, and then we just train the classifier. Okay, we don't really care about this, so we can skip all of this. Let's just maybe skim the what's so novel about the NLLB model. Well, I guess mostly the scope, the data in the scope, in the sense, the scope of the number of languages that they support. So that's 202 languages for over 40,000 language directions, whereas previous systems were supporting way less. That's kind of the main thing, and there's a bunch of details about, they tried mixture of experts, a model that has 54 billion parameters, and that one performed the best for all 40,000 directions. So it's mostly, I guess, preparing the data, mining the data, everything combined. It's just like a project. It's not, there is no single thing that distinguishes them from the baselines. Hope that answers your question, Martin. Encode load. So we're just encoding stuff here and here as well. No worries. You're welcome. Okay. Let's go here. I think we'll be done soon with the laser code base. We can start building stuff after this. Step by step. This README shows how to calculate. I'm still thinking whether we should use Versec or just switch to GPT-NeoX. If we switch to GPT-NeoX, then maybe we can take a couple of days to just get familiar with the code base, and then we can start re-implementing NLLB there, and then training the checkpoints. Let me just note that somewhere. Okay. XSim. This README shows how to calculate the multilingual similarity error rate for a given language pair. Given a bytext with source language embeddings and target language embeddings Y, XSim aligns the embeddings from X and Y based on margin-based similarity and then returns the percentage of incorrect alignments. 3 different margin-based, yeah, we use ratio so far. They mostly use ratio. Okay, example usage. Simply run the script eval sh to download a sample dataset, floors 200, a sample encoder, laser 2, and calculate the sentence embeddings and XSim error rate for a set of comma-separated languages. You can also calculate XSim for encoders hosted on Hugging Face. For example, to use labc, you can add the following arguments in the sample script. Okay, you can just specify labc here, specify we want to use Hugging Face. Okay. Okay, let's see what's happening here. XY. Margin selection. Okay, this is just how do we use it. and then there is the eval sh script. Data directory, we download floors, we download potentially models as well. Blazor, no, NLLB laser too. Okay, and then we call the eval script. Okay, and the eval script, we kind of skimmed it before. If I open up this one, eval, okay, might be fun to run this one. Okay, and then let me just skim this last one. I think we might be able, we should run the xsim just to understand a bit better how that metric is computed. It's oftentimes mentioned just to get some understanding. Okay, let's see what's going on here. xsim++, how to calculate error rate for a given language pair, extension of the previous metric, target site data with additional synthetic, hard to distinguish examples. More details in that paper. Example usage, simply run the eval. To download the sample dataset, same as previously, download synthetically augmented English evaluation data from floors, a sample encoder, and calculate both the sentence and the for a set of comma-separated languages. Similar to xsim, however, there is an additional option to provide the comma-separated list of augmented languages. These refer to languages in the chosen evaluation set, which also have a separate augmented data file. Okay. You can also calculate xsim++ for encoders hosted on Hugging Face sentence transformers. To use LabC, blah blah blah. Okay, same rationale as in the previous task. Let's see what's going on here. Okay, so they just call, let's kind of put them side by side because these are fairly similar, if not the same, almost. Close all. Let me just open up this guy, eval, put it here, and then this eval, and put it here, and let's just see side by side. Okay, source languages. So here additionally they specify target and target augmented, and that's it. So everything happens in the eval script really. Okay, then we can maybe run, this is the last task we'll run in laser, and we are done with laser, and then we can jump to the next tasks. Analyzing, deciding on the framework we want to use to train. Might be worth a while to just skim a bit through the GPT-NeoX codebase to get some knowledge myself on how it looks like compared to FairSec. So I think we might be running some examples there as well, and then we can start training the checkpoints. The first checkpoints for bigger ones, we'll need to in parallel reach out to Lion, stability, see how we're gonna handle the compute part. Okay, let's run this script. Eval sh. Where are the models? Okay, we're gonna download the laser 2 PT. We already have it, but in a different directory. We have it in the external tools there. We did download those checkpoints somewhere. Okay, so that's gonna download the floors and then models. And then we're gonna call the eval script. Okay, let's do it like this. Because we're gonna manually run this, we can step through the whole script. We're going to echo all of the arguments as usually. Let's just echo all of this. And then we can comment out this line. We can go here, clear the screen, navigate to xsim, and then basically bash eval. That's gonna again download the floors dataset right here, which we currently don't have, and then it's going to download to models the laser checkpoints. Okay, let's see how that changes. Let's run this. So again, we're downloading floors. Here we can see how the tar archive was downloaded, and now we're downloading the checkpoints, and we are done, and we finally have the necessary parameters here for the script. Okay, so let's see. Floors is here. It just contains, this is Arab language, Arabic language, Arab language, English, etc., etc. Okay, that's the dev split. Let me close down this file. Let me see whether we have, okay, we have laser 2 checkpoints, vocab, and SPM here. And now finally we can go to the launch config, add a configuration. Let's add a config here. I'm just gonna create yet another config and then specify the arguments here. Let me just split this to the right. Just a second. Let me close down a bunch of this. We don't need half of these. Okay, split right, and then let's go back to the tasks here, and let's see the arguments. Okay, so what we need is base directory, and then we need what we printed out here. This is the base directory, and then we have the corpus, and the corpus is just floors 200, and then we have the corpus part, and that's gonna be dev test. Again, just following the printed out versions, the argument from here. Dev test. Let's just try. And next up, margin ratio, source encoder. It's going to be laser followed by models. So again, just something like this, and then followed by models followed by laser 2. And then similarly, we do the same thing for SPM model, and we just change it to SPM there, the suffix. We just copy the same path and we modify the suffix such that we have SPM. Okay, and finally, source langs. Let's copy this. Okay, and let me wrap it up by adding n-way verbose. 2 more arguments. Okay, with this, let's just change this to xsim, and let's org to just eval xsim. And then let's go to actual eval script. So that one is stored under source eval. And then we can just put a breakpoint somewhere here. So this is, I guess, the main function. Let's put a breakpoint here and let's run it with the new config eval sim. Okay, let's run this. Might take a while. Let's see what's going on. Base directory or evaluation files. Corpus part. This should be called split, not corpus part, but okay. Margin, mid-sense, only use test sets, n-way, index comparison. Okay, there is a ton of arguments there. Quick sort, embedding dimensions. Okay. And then we just call run eval. Let's put a breakpoint there, and let's put a breakpoint in the eval init method. and one here, one here, one here, here as well. Okay. So just waiting for this to start. How are you guys using these streams? Are you just using to study with me, or are you actually following some of you? I know that from time to time people come and actually follow. I got a lot of useful feedback over the last couple of days for some things in Ubuntu, how to do some stuff. So that was super cool. Or are you just stalking me? Which is also fine. I'm stalkable. I'm thinking whether I should just restart my system. This is just so painfully slow. I never experienced this on Windows. Okay, just analyzing while I'm waiting this. Starting out reading papers. Check out some of the videos I made for paper reading, especially the early days, like in 2020. It takes some practice to learn how to read papers. Like, you have to do it. Start by just reading the abstract, forming a high-level mental model. There's a couple of good blogs. I think Andrew Yang wrote a blog on how to read papers. There's plenty of resources of people describing how they read papers. I think you can find easily a blog online. There is no special magic trick. Okay, let me just kill this process. Something is not okay. Okay guys, I'm gonna go and restart my machine. This is becoming unbearably slow. I'm gonna stop the stream and restart in 3-4 minutes. See you soon. Let me just stop it now.